Hello everyone, this is my second day discussion. I am Amit Kumar Mondal and today I am going to teach you basic physics. Previous day I was in a chapter named Current Electricity, and today I will discuss you on the topic of Wheatstone Bridge. And there are some topic I will cover in my description in my discussion. One is description of Wheatstone Bridge, working principle of Wheatstone Bridge, and the proof of the working principle of the Wheatstone Bridge, discussion about Wheatstone Bridge, and some applications on depends on the principle of Wheatstone Bridge. Okay. So first of all, this is the description of a Wheatstone Bridge. So what is Wheatstone Bridge? Wheatstone Bridge is basically a device that can measure some unknown resistance. The unknown resistance may be R here, okay, and this is made, the Wheatstone Bridge is made of 4 arms of resistance P, Q, R, S connected each other to form a diagram. Looks like quadrilateral system. It looks like a quadrilateral system, and the galvanometer is connected in the P and Q junction and the S or R junction, and the battery is connected in the opposite junction, means P and S junction and the Q and R junction. Okay, and this type of diagram is correct. Also, this type of correct diagram is correct, means here galvanometer and the battery is interchangeable, means if we interchange G here and battery here, there is no difference of the circuit or the principle of the circuit. So both diagram is equally correct, and this both diagram represent the Wheatstone Bridge diagram. So 4 resistance PQ RS are connected to form a quadrilateral. The galvanometer and the cell are connected diametrically opposite to each other end, as shown in the figure. The whole system is called Wheatstone Bridge. Clear? Okay. Next slide. Working principle of a Wheatstone Bridge. A Wheatstone Bridge is a system where there is a battery, positive terminal and negative terminal. So current flow from the positive terminal towards the negative terminal, and here current flow in the two division I1 and I2. And here I1 can be divided into position here and also here, and I2 can be divided into position here and also here, and the whole current I1, total current I1 goes in the negative direction of the battery. But this is the case of normal condition, that current can flow through the galvanometer in that way or in that way, depending on the value of the current can flow in that direction or in that direction in the galvanometer, in the normal condition of the Wheatstone Bridge. Now what is the balance condition? The balance condition is when there is no current flow across the galvanometer. When there is no current flow, that means this current can flow here only, it cannot current in the galvanometer, or I2 can flow here only, I2 cannot go in the galvanometer, then this type of condition is called balance condition. So balance condition is a condition when current passes through the galvanometer is 0, or 0 current passes through the galvanometer, then the bridge is said to be in balance condition. Okay, and in that balance condition one can easily say that P by Q equals to R by S, means P by Q equals to R by S. This is the condition of balance condition. But one may ask to me that why it is valid, why P by Q equals to R by S when there is no current flow in the galvanometer. Okay, this is in the next slide where I can prove that why P by Q equals to R by S. So first of all, we have to consider that there is no current flow in the galvanometer, means this type of direction of current and this type of direction is current is zero. There is no current flow in the galvanometer. By considering this, we can say that I1 is totally goes through P, and this I1 can flow through Q. So I1 here is same as to I1 here. Okay, so in that diagram, AB, VA minus VB, VA minus VB equals to I1 into P. Why? From the Ohm's law, we can say that voltage drop equals to current into resistance. So voltage drop here, VA minus VB equals to I1 into P, and here VB minus VC is the voltage drop equals to current into resistance, I1 into Q, I1 into Q. So if I divide whole term, VA minus VB equals to VB minus VC equals to P by Q. Why? Because I1 and I1 is cancel out. So P by Q, VA minus VB equals to VB minus VC equals to P by Q from that equation. And again, from the second path I2, VA minus VD is a voltage drop across R. So VA minus VD equals to I2 into R. VA minus VD equals to I2 into R. And the same way, VD minus VC. VD minus VC is a voltage drop across S. VD minus VC equals to current into resistance, I2 into S. I2 into S. So divide the whole equation, VA minus VD by VD minus VC equals to R by S. Why? Because current I2 I2 are same and can be cancel out. So in the balance condition, means when there is no current flow across the galvanometer. So why can the galvanometer does not flow any current? No, but why in that part there is no current across the galvanometer? That means that in the balance condition there is no flow of current across the galvanometer, means the potential across B at the point B and the potential at the point D is same. So there is no current flow because the potential is same. So VB, potential at point B and the potential at point D is same. So VB equals to VD. Okay, that's why current cannot flow through the galvanometer, because the potential here and the potential here is same. So VB equals to VD. So by knowing the condition VB equals to VD, put here VD equals to VB and VD equals to VB. So VA minus VB by VB minus VC equals to R by S, that is same as there. So VA minus VB by VB minus VC equals to P by Q equals to R by S. From that equation we can say P by Q equals to R by S. This is the balance condition. So we can prove now, we have been proved that P by Q equals to R by S is the balance condition when there is no current flow across galvanometer, means when VB equals to VD. Okay, that's all for that. Now we are discussing about the Wheatstone Bridge. How can a Wheatstone Bridge works properly or in a very sensitive way? So very high or very low resistance cannot be measured by this method. Okay, so first of all, if one can think that if I know P, if I know R, if I know Q, I can measure S from that equation, from the balance equation. We can measure unknown S from the balance equation. That is wrong if the P, Q and R are very much high resistance or very much low resistance. In that two type of condition, R cannot be measured accurately, because in that two condition the galvanometer was not that much sensitive to gives the balance condition. Okay, so in the very high resistance and the very low resistance, the unknown resistance, the galvanometer cannot be worked properly. But if it is most sensitive when the resistance in the four arms are almost same, but it is most sensitive when the resistance P, Q, R, S are almost same, then we can measure the unknown resistance S very easily, because then the galvanometer works very smoothly or very properly. So the total circuit will be very much sensitive to measure the unknown resistance S here. Okay, so it is most sensitive when the resistance of the four arms are almost same. Now the second point, the balance condition remains the same if the position of the galvanometer and the cell be interchanged. So as I told before, that the galvanometer and the battery can be interchangeable, can be interchanged, and there is no change in the balance condition if I interchange the galvanometer and the battery in their own position. So if I interchange galvanometer and the battery position, the balance condition is not violated. This is the main thing. My third point is, balance condition is independent of current, resistance of galvanometer and EMF of the cell. Means what type of battery you are using, what type of galvanometer you are using, and how much current flow in the circuit, it is not that much important if I say the circuit is in balance condition. So the balance condition is a condition that cannot be depend on the battery, on the galvanometer, and on the how much current is flowing on the circuit. It only depends on the P, Q, R, S. So the balance condition is independent of the current flow of the circuit, independent of the battery are using, the independent of what type of galvanometer we are using. It is only depend on P, Q, R, S. Only the four resistance are dependent and all other things are independent for the balance condition. Okay, now the fourth point is, if the galvanometer is connected between the junction of two highest resistance and the two lowest resistance, then the bridge will be most sensitive. Means suppose we have different type of resistance, P is different, R is different, Q is different and S is different, but in all the four arms of resistance, P and Q are highest resistance than R and S. If that is the condition, the galvanometer works more properly, or the galvanometer works as a works very sensitively. Okay, so if the galvanometer is connected to a junction when P and Q are the highest resistance or P or Q are the lowest resistance, then this circuit works very accurately, or this is the most sensitive circuit. Okay, so the galvanometer is connected to the junction of the two highest resistance and the lowest resistance, the bridge will be most sensitive. Okay, my next topic is, what is the application of Wheatstone bridge? We have already done some experiments in our practical classes, that is meter bridge experiment and the post office box experiment. Both these two type of device depend on the principle of Wheatstone bridge. Okay, this is a circuit diagram of the meter bridge, and this is a circuit diagram of PO box, the post office box, and both these equation devices based on the principle of Wheatstone bridge. We have already discussed on the practical classes, so I am not here to discuss the details of the circuit here, meter bridge and the post office box. But one thing you have to remember, that meter bridge and post office box are the devices that works on the principle of Wheatstone bridge. Okay, that's all for today. Thank you.